Section 6.3, volume and surface area. So we'll do like the last one, we'll just walk through all the problems and I'll give you some tips. And this one says find the volume of the figure. You can see all the sides are the same. So you can either treat it as a cube or a rectangular solid, whichever one you want to. Since it's a cube, it makes it super easy. It's just going to be 15 times 15 times 15, or 15 cubed. And that is why we call it cubed for third power. Or length times width times height, and you'll get the same answer either way there. That one. And so that one's not too tricky, that one's pretty straightforward. So let's spend our time on the trickier ones. Okay, this one says find the surface area of the figure. And on this one, it is a lot easier if you see that they're all the same. So this would be the surface area of a cube. Okay, so surface area of a cube, we have a cube and we want the surface area going to be 6 times the side length squared. Okay? Because what we're doing is we're figuring out the area of each face and adding them together. But here, each face is going to be 17 times 17. And we have 6 sides on the cube, right? We've got front, back, left, right, top, bottom. Okay, so this is kind of nice. So we would just do 17 squared times 6 to get the surface area here. Because we've got 6 sides. We've got 6 sides, and for each side is going to be 17 times 17 will be our area. So 17 squared. All right, this one says find the surface area of the figure, and it gives us a cylinder. I'm sorry I put this one in here, I didn't really mean to. So we want the surface area of a cylinder. Okay. Then let's go to Google. Okay. It's a formula that I can never remember because it's kind of long. You can think your way through it, but okay, so if we have a cylinder, computer's been slow. What we're going to do is you can think about it kind of like cutting down the side of the cylinder and flattening it out. That will turn the big side into a rectangle. Okay, so for it would be the radius times the height times 2 pi. And then to get the top and the bottom piece, they're going to be the same, so we multiply by 2. They're going to be the same circle, and for a circle, it's pi r squared. Okay, so just look at the formula and fill in numbers, okay, if you need to. So our radius here is 3, and our height is 6. Okay, so h is 6, and then we would just plug in. Remember, we're using 3.14 for pi on these. I never remember that one. I'm kind of sorry I put that in there. The formula is just so long. Okay, this one says find the volume. Okay, that's not as bad. So if we want the volume of a cylinder, we want the volume of a cylinder, then it's going to be the area of the top or the bottom, so that's pi r squared, times how tall it is, h. Remember, we're using 3.14 for pi, so it'll be 3.14 times 5 squared times our height, which is 4. And we'll get our answer in cubic meters. When we're doing volume, our units are always going to be cubed, or to the third power. And so the difference between volume and area. Okay. Number 5 says find the volume. If you see anything rectangular shaped, man, that's nice to see because it's easy. You just do 12 times 3 times 6, and it's going to be cubic centimeters. The rectangular stuff's really nice when you get into higher dimensions. But this one says find the surface area. Find the surface area. So we're 12 feet across, 7 feet deep, and 8 feet tall. I can't draw, you've seen that, so I definitely can't draw 3-dimensional stuff. But what we can do is we can think about what the 3 different types of sides would look like. Okay, so one would be, we would have a pair of sides that were 12 by 8. And then we would have 2 more sides what was our other dimension? Sorry, our other dimension was 7. So we would have another pair of sides that would be 8 by 7. And then we would have 2 more sides that would be 12 by 7. So what we're doing is we're taking, so maybe this is like front and back, and then the middle one is top and bottom, and then we've got left and right for the last one. Okay, so what we're going to do, so if we do 12 times 8, that's 96. Do 8 times 7, that's 56. And if we do 12 times 7, the area of this one is 84. But we've got 2 of each one of these. Okay, so we're going to have to do 2 times 96, so maybe front and back, plus 2 times 56, so maybe left and right sides, plus 2 times 84, so top and bottom. And if you look at the formula, that's kind of what the formula looks like. Okay, so there, if we did 2 times 96 plus 2 times 56 plus 2 times 84, we get 1,432. And I think it was centimeters, so it'd be centimeters cubed. Let's check that. Oh, feet. Okay, so it'd be, yeah, and it's surface area, so it's not even cubed. It's squared. Right? So feet squared. Sorry about that. Short-term memory is not what it used to be. Okay. And so that looks confusing, but if you kind of reason through it, it helps. Okay, you got 2 sides that are the same, so left, right. 2 sides that are the same, top and bottom. 2 sides that are the same, front and back. So you figure out the area of each one of those and multiply it by 2 and add them all together and get the surface area. See what's next. Okay. This one, we've got a swimming pool. We're painting the outside of an above ground pool. How many square feet of paint we need to cover? Okay, so we're just painting the outside. Okay. So all we're doing is we're taking the surface area of a cylinder, but we're not using the top and bottom part. Okay, so let's go back to that formula. Surface area of a cylinder. So this is the sides, right? And then this 2 here, where we got power squared, that would be the top and the bottom. So you just leave this part out of the formula on this one, okay? Because we only want the area on the sides. So it'd be 2 pi RH. And we're not painting the top, we're not painting the bottom. Okay. For 8, we got a fish tank, and it doesn't tell us, but it's going to be rectangular solid. So not curved or anything. We've got a rectangular solid here that needs to hold 7,020 cubic inches of water. The tank is 30 inches long, 18 inches wide. How tall will it need to be? And normally we do length times width times height. So we would have 30 by 18 times however tall it is, h. And when we do that, we have to get, what do we have to get? 70/20. So what we can do 30 times 18 is 540 times h, or 540h, equals 70/20. And then we divide both sides by 540. So h is going to be 70/20 divided by 540. H is going to be 13. Okay. I think it's inches. Is that right? Yeah, 13 inches is how tall our tank is going to be. Oops, sorry, there's my formula cheat sheet there. Oh, and I think I forgot to mention on the other video, I will give you all these formulas on test day. Okay, so there's nothing wrong with using the formulas when you work through them. So I'll give you some type of formula sheet like this where it's got them labeled. Okay, and then you just can pick out the formula you need for the right shape, whether you're finding area or volume or surface area, and then plug in. So you just need to know how to use the formulas. Okay. Number 9. See, what's the volume of the silo? So we need to do the volume of a cylinder. Okay, so this time be careful, it gives us a diameter is 12 feet. So if the diameter is 12 feet, the radius will be 6. And the radius is what's in the formula. So we'll have pi times 6 squared times the height of 28. So 3.14 times 6 squared times 28 on this. That's the only tricky part there, is that it gives you the diameter and the formula uses the radius. We're going to seal the inside of the sandbox. It gives us the dimensions. How many square inches will the sealant need to cover? Okay, so if we're sealing the inside of the sandbox, that means we're not going to put any on the top. Okay. So it's just the surface area of the rectangular solid. But when we talk about the top, so the top would be 46 by 30. So when we do that side, and let me go back to our picture here. So when you do the side that would be the top, the 46 by 30 side, you're not going to multiply it by 2. You're just going to just have a 1 here. So you do the bottom. And so you still do left, right, front, back. But then when you do the one that's the top, top and bottom, you're not going to multiply by 2. Okay, you're just going to write down whatever that number is, because we're not going to put any kind of sealant on the top of the sandbox. Okay. One more here. Oh, and this one's a nice, easy one to end on. How many cubic feet of concrete do we need for this foundation? It gives us the dimensions. They're all in feet. So it's a rectangular solid. So guess what? We just multiply 67 times 52 times 4. We'll figure out how many cubic feet of concrete we need. Okay, so if I rush through any of those too fast, you have questions on them, just let me know. Any questions, just send them to me. Okay.